In this lesson, you're going to learn about the Common Media Application Format, or CMAF. We'll define what CMAF is, detail its current status, and look at the issues relating to implementing CMAF. Let's look at the problem that CMAF is designed to solve, and that specifically is supporting multiple ABR formats. So we've got multiple sets of clients out here. This one plays M3U8 files, which is HLS, MPD is dash, this is IMSC, which is smooth streaming, and this is FRM, which is HDS. So to serve these clients, we're creating 4 sets of files, these files here, which often means 4 times the encoding cost and 4 times the storage at the origin server, which is expensive storage. Now, we just had a lesson on transmuxing, or just-in-time packaging, which eliminates a big portion of this problem. And with just-in-time packaging, you have a single format in, and it can be VOD or live, and you create your multiple bit rate, and essentially your encoding ladder, upload that to the streaming endpoints. You've got one set of files stored here, one set of files encoded, and then you package dynamically. And that's fast and efficient because you're only adjusting the file header container format. You're not messing with any of the compressed video data. And the issues are you need a server component. This is Microsoft Azure. They're keeping the server alive for you, but you're going to get charged for that. If you do it yourself, you're going to need a server like Wowza or Nimble Streamer, and that's going to cost extra money both for the license of the server and for keeping it alive in the cloud by running an AWS instance. And that's this here. So what is CMAF? CMAF is a new container format that can hold fragmented MP4 files with both dash and HLS support and multiple sets of manifest files, so you can include dash, HLS, smooth streaming, HDS in the same set of files. It's not a new ABR format. It doesn't directly compete with dash and HLS. Instead, it's a container format that enables one set of files with multiple sets of manifests to serve multiple ABR formats. Or more graphically, if you create separate HLS and dash packaging, you've got the video files here, the manifests here for HLS, the video files here, the manifest files here for dash. On the other hand, if you do it solely with CMAF, you've got one set of fragmented MP4 files here that serve both the clients. You've got the MPD and the M3U8. So instead of having to upload 2 sets of files to the origin server, you upload one set of files here. And to be clear, you don't deliver via CMAF. You store your files in a CMAF container and deliver via HLS or dash. The original problem with CMAF related to encryption. So when launched, there were 2 incompatible encryption schemes, CBC, cipher block chaining, which Apple used, and CTR, counter mode, which almost everyone else used. So before CMAF, you needed separate files for dash and HLS. After CMAF, you needed separate files, CMAF encrypted with CBC and CMAF encrypted with CTR. Since then, Google supports CBC and Widevine, PlayReady supports CBC and PlayReady 4, and most devices now support CBC. So now we get the true promise of CMAF, where we have a single set of files, CMAF here, encrypted in CBC. So where are we with device and browser support for CMAF? Over 95% of all iOS and tvOS devices support CMAF via HLS. Over 97% of Android devices support CMAF via dash or HLS. Roku supports CMAF via HLS and dash, and all major desktop browsers and many lesser ones support CMAF, and all that's required to support the media source extensions for playback and the encrypted media extensions for DRM, which most current versions of browsers do. So what are the challenges relating to implementing CMAF? We just talked about the CBCS compatibility, but that's only a problem if you are using DRM. CMAF does not allow muxed audio, so that is a huge problem if your existing libraries and advertising support use muxed audio and video files. And CMAF may not be fully supported by advertising servers, but this is improving by the day, and it's also only a problem if you're monetizing your video with advertisements. And here's the checklist for implementing CMAF. The encoder workflow should be pretty simple because most supported at this point. Ads packaging workflow is going to depend upon the ad server. DRM, if applicable, that may be problematic as we've discussed. Player and dev testing should be relatively straightforward at this point because CMAF is getting more and more mainstream. And with low latency, you have to decide whether you want to wait and implement low latency with your first CMAF implementation or implement CMAF first, and then a low latency CMAF solution. So when will CMAF become a reality? If you're not using DRM or advertising today, you should be exploring CMAF today. You may lose some legacy players, but those numbers are getting very much smaller making CMAF much more viable. If you are using DRM in advertising, you should still explore. Most services like Turner, NBC, and Brightcove expect to distribute CMAF as an additional format along with HLS and Dash for at least several years. And there's also the issue of whether you're a new service versus an old issue. So Disney Plus launched with CMAF only, but because it was a new service, they didn't exclude any current customers. If you want to switch over to CMAF, you risk pissing people off because all of a sudden the device they're using may not be compatible. And here's some resources for reading up on CMAF.